how do we objectively prove who actually influences public policy in a modern democracy when we look at the data? In 2014, researchers Martin Gilens and Benjamin Page attempted to answer this exact question. They compiled an exhaustive data set of 1,836 individual policy issues spanning 2 decades, matching public opinion surveys against the final laws passed by Congress. Their conclusion became a landmark finding in modern political science. Economic elites dominate policy outcomes, while the preferences of the median citizen have a near-zero independent impact on what the government actually does. Despite the fame of this finding, the statistical methodology used to achieve it is paralyzed by a known mathematical flaw. If the mathematical tools we use to measure democratic responsiveness are structurally broken, our understanding of political power is entirely blind. To measure influence, political methodologists rely almost exclusively on a standard statistical tool, multivariate linear regression. Linear regression requires distinct data clusters to draw separate lines and isolate independent variants. But the Gilens dataset destroys this. Citizen and elite preferences correlate at a massive 0.94. This multicollinearity means sharing 94% of variance causes regression coefficients to become completely unstable. Because of this multicollinearity, the academic debate surrounding elite versus citizen influence remains stuck in a methodological deadlock. Finding the true signal in this data requires abandoning parametric models entirely. We must measure the total statistical dependence without forcing the data into linear assumptions. To accurately measure representative democracy, we have to evaluate the government using the exact same mathematics used to engineer fiber optic cables, Claude Shannon's information theory. In 1948, Claude Shannon published the foundational mathematics of all modern communication. Shannon showed that data transfer can be modeled as a discrete memoryless channel. Every system has a source signal, an encoder, a transmission channel, and a decoded output. We can map the American political system directly onto this architecture. The public's aggregate policy preferences act as the system's source signal. The legislative institutions, Congress, the committees, and the executive branch, function as the transmission channel. The final binary policy outcome, whether a proposed change is adopted or rejected, serves as the decoded output. Inside that channel, variables like campaign finance, interest group lobbying, and institutional friction act as adversarial noise, degrading the signal. Representative democracy is a communication network. Its responsiveness can therefore be measured objectively as a precise bitrate. This equation calculates Shannon entropy, represented as h of y. Given a baseline 35% policy adoption rate in the Gilens data, the total uncertainty of a policy passing before we observe any public preferences is exactly 0.934 bits. Mutual information measures the exact amount of that initial uncertainty that gets resolved once we know what the public actually wants. When we run the math on the citizen-to-policy channel, the empirical measurement shows it transmits a minuscule 0.025 bits of information. This bar chart visualizes the resulting channel efficiency. Citizen preferences resolve so little uncertainty that the channel operates at exactly 2.7% of its theoretical capacity. The elite channel fares only marginally better. It transmits just 0.037 bits, operating at a 4.0% efficiency rate. No telecom engineer would accept a specification where 96% of the input is lost to noise. Both political channels operate at near zero efficiency. This severe data loss prompts an obvious academic critique. Does the channel transmit less citizen information simply because the public's preferences are inherently more diffuse and contradictory than those of the elites? These identical waveforms model source entropy, the metric used to determine the structural dispersion of a signal. The source entropies are virtually identical, at 3.116 bits versus 3.088 bits. The citizen preference signal is mathematically just as precise as the elite signal. The massive data loss is an active failure. The democratic channel selectively attenuates the citizen signal based entirely on source identity, not signal quality. Elite influence of 1.7x means nothing when both signals are crushed by 96% noise. We are analyzing a severed transmission line. Is the democratic channel entirely dead, or does it simply transmit certain types of signals better than others? To find out, we have to look outside the Gilens data. An independent validation test compares the broad, macro-ideological public mood against actual congressional voting records over several decades. This diagram illustrates the concept of a low-pass filter in electronic signal processing. High-frequency inputs hit the filter boundary and immediately flatlines. Specific issue-by-issue policy demands from the public act exactly like high-frequency noise. The system blocks them, yielding that 3% efficiency rate. But the broad thermostatic shifts in public macro ideology act as the low-frequency DC component of the signal. When we measure the transmission of these broad ideological shifts, efficiency jumps dramatically to nearly 29% capacity. The architecture of the government is a filter. It reacts dynamically to broad, slow-moving ideological shifts, but operates as a severed wire when presented with precise, high-frequency policy demands. The policy-level data loss begins at the point of origin, through a process called encoding loss. Plurality voting at the ballot box violently crushes a high-dimensional citizen preference vector into a single, low-bandwidth binary choice. This is not true Shannon data compression, which efficiently preserves information. This is the forced destruction of data, projected onto an axis defined entirely by the candidates. If the system suffers from massive encoding loss right at the input stage, simply trying to reduce elite lobbying influence later in the channel will not restore responsiveness. Real reform requires systems engineering. The network needs an increased sampling rate of public opinion and an upgraded encoder utilizing better ballot mechanisms to preserve preference data. Claude Shannon's mathematics finally provide the objective, non-parametric diagnostic metrics required to benchmark these systemic upgrades. Representative democracy's failure to enact the public will is a mathematically measurable engineering failure, and we now have the exact tools required to solve it.